Have you ever looked up at the night sky and wondered about the vastness of space? The sheer enormity of it all can be overwhelming, yet it also fills us with a sense of wonder and curiosity. Billions of stars twinkle like distant diamonds, each one a sun in its own right. These stars, scattered across the cosmos, are part of a grand celestial dance that has been ongoing for billions of years. But amidst this celestial tapestry, there are wanderers, celestial bodies that roam the cosmos, planets. These planets, including our own Earth, follow intricate paths dictated by the gravitational forces of their parent stars, and sometimes their paths intersect in the most dramatic ways imaginable. These cosmic encounters can lead to spectacular events, from near misses to catastrophic collisions. What if I told you that one day our very own planet Earth could collide with another? This scenario, while highly unlikely, is not entirely outside the realm of possibility. It might sound like something out of a science fiction movie, but the possibility, however remote, is a stark reminder of the immense forces at play in our universe. The gravitational pull of planets, stars, and other celestial bodies creates a dynamic and ever-changing cosmic landscape. Mars, our reddish neighbor, has long captured our imagination as a potential second home for humanity. Its surface, with its valleys, mountains, and potential signs of ancient water, beckons us to explore and perhaps one day settle there. But what if, instead of a friendly neighbor, it became the harbinger of our destruction? The idea of Mars veering off its orbit and heading towards Earth is a chilling thought. The idea of Earth colliding with Mars is a sobering thought experiment, forcing us to confront the fragility of our existence and the awesome power of the cosmos. Such an event would be catastrophic, altering the course of life on Earth forever. It's a cosmic game of billiards with stakes higher than we can fathom. The planets, like billiard balls, move through space, occasionally colliding with one another in a dance of destruction and creation. While the likelihood of such an event is infinitesimally small, the sheer scale of destruction it would unleash is a potent reminder of our place in the grand scheme of things. The forces at play in the universe are beyond our control, and we are but tiny specks in the vast cosmic ocean. Join me as we delve into the science behind planetary collisions, explore the potential consequences of such a cataclysmic event, and discover what, if anything, could survive in the aftermath. We'll look at historical collisions, both in our solar system and beyond, and what they can teach us about the future. Buckle up, space cadets, it's going to be a bumpy ride. As we embark on this journey, we'll uncover the mysteries of the cosmos and gain a deeper understanding of the forces that shape our universe. The universe, for all its beauty, can be a chaotic place. It's a vast expanse filled with countless stars, planets, and other celestial bodies, all moving in a seemingly random yet intricately choreographed dance. Far from the serene and unchanging picture we often imagine, celestial bodies are in constant motion, locked in a delicate dance governed by gravity. This gravitational ballet ensures that planets orbit stars, moons orbit planets, and even smaller objects like asteroids and comets follow their own paths through space. This celestial ballet, while mesmerizing, isn't without its mishaps. Occasionally, these paths intersect, leading to spectacular and sometimes catastrophic collisions. Collisions between planets, while rare, are a testament to the immense forces at play in the cosmos, shaping the very fabric of our solar system. These collisions can result in the formation of new celestial bodies or the destruction of existing ones, altering the course of cosmic history. Billions of years ago, when our solar system was still in its infancy, planetary collisions were far more common. The early solar system was a chaotic place, with countless protoplanets and planetesimals jostling for position. Think of it as a cosmic game of billiards, with planets as the balls, careening off each other in a chaotic frenzy. Each collision had the potential to create new worlds or destroy nascent ones, contributing to the dynamic and ever-changing nature of the cosmos. Over time, these collisions led to the formation of the planets we know and love today, including our own Earth. The debris from these impacts coalesced to form larger bodies, eventually giving rise to the stable planetary system we observe now. The evidence of these ancient impacts is etched across the face of our solar system. Craters on the surfaces of planets and moons serve as a testament to the violent history of our cosmic neighborhood. Our moon, for instance, is believed to have formed from the debris ejected when a Mars-sized object slammed into Earth billions of years ago. This colossal impact not only created the moon, but also significantly altered the Earth's composition and tilt. Similarly, the tilted axis of Uranus, spinning on its side like a cosmic top, is thought to be the result of a collision with a massive object early in its history. This impact likely caused Uranus to tilt dramatically, giving it the unique rotational characteristics we observe today. Today, the solar system is a much calmer place with planets confined to their orbits. The chaotic early days have given way to a more stable and predictable arrangement, allowing life to flourish on Earth. But the potential for collisions hasn't vanished entirely. Asteroids and comets, remnants from the formation of our solar system, still pose a threat. These wandering celestial bodies can occasionally cross paths with planets, leading to potential impacts. Asteroids and comets, remnants from the formation of our solar system, still pose a threat, as evidenced by the numerous impact craters scarring the surface of Earth and other planets. These craters are reminders of the ongoing dynamic processes that continue to shape our solar system. These celestial interlopers, while smaller than planets, can still wreak havoc, as the dinosaurs learned the hard way millions of years ago. The impact that led to their extinction is a stark reminder of the potential dangers lurking in the cosmos and the ever-present possibility of future collisions. Imagine this: a day like any other. Birds are singing, children are laughing, and then, the sky begins to change. A reddish-orange dot, once a familiar sight in the night sky, grows larger, brighter, and undeniably closer. It's Mars, no longer a distant neighbor, but a harbinger of doom, hurtling towards Earth with terrifying speed. The moment of impact would be unlike anything witnessed in human history. The energy released would be equivalent to billions of nuclear weapons detonating simultaneously, instantly vaporizing a vast area around the impact zone. Imagine an explosion so powerful, so bright, that it makes the sun look like a flickering candle. The shock waves from the impact would ripple across the planet at supersonic speeds, triggering earthquakes of unimaginable magnitude, far beyond anything ever recorded on the Richter scale. Mountains would crumble, oceans would boil, and the very landmasses we call continents would be reshaped like putty in the hands of a cosmic giant. The atmosphere, our protective blanket, would be the first casualty, superheated and blasted away into space. What remains would be choked with dust and debris, plunging the planet into a perpetual twilight. The skies, once a canvas of blue and white, would turn a sickly yellow, then orange, and finally a deep, blood red as the sun, obscured by the dust cloud, casts an eerie glow upon the devastated landscape. In the fiery crucible of a planetary collision, where celestial bodies clash with unimaginable force, survival is a long shot, a near impossible feat, a cosmic lottery with odds stacked heavily against life as we know it. The sheer magnitude of such an event is beyond comprehension. The immediate aftermath of the impact would be a hellscape, a scene straight out of our worst nightmares, an inferno of unimaginable proportions. Volcanic eruptions would spew molten rock and ash into the sky. Temperatures would soar to thousands of degrees, creating an environment so hostile that survival seems impossible. Hot enough to melt rock and vaporize anything in its path. Imagine a global wildfire engulfing every forest, every city, every structure, every living thing in its path. The oceans, once teeming with life, would become giant cauldrons boiling away into the atmosphere, leaving behind barren, lifeless basins. The very essence of life, water, would be stripped away. The very air would become unbreathable, a toxic cocktail of superheated gases and vaporized rock, creating an atmosphere that would choke and suffocate any remaining life forms. The sky would be darkened by ash clouds, but even in this apocalyptic scenario, life, tenacious and adaptable, might find a way. Life has a remarkable ability to endure. Deep beneath the Earth's surface, shielded from the worst of the heat and radiation, there could be sanctuaries where life clings on. Extremophiles, organisms that thrive in extreme environments, could potentially weather the storm. These hardy survivors, accustomed to the harshest conditions Earth can throw at them, might just hold the key to life's persistence in the face of cosmic adversity. These organisms have been found in the boiling hot springs of Yellowstone, in the crushing depths of the ocean, and even in the radioactive ruins of Chernobyl. Their resilience is nothing short of extraordinary, and they might just be the torchbearers of life in a post-apocalyptic world. Then there's the possibility of life finding refuge in the most unlikely of places, space itself. The impact would eject trillions of tons of rock and debris into orbit, some of which could harbor microbes, flung into the void like seeds on the cosmic wind. These microbial voyagers, dormant and awaiting their chance, could potentially carry the spark of life to distant worlds, seeding the cosmos with the potential for new beginnings. Imagine a single microbe, hitching a ride on a piece of space debris, traveling through the vast expanse of space, and landing on a distant planet. There, in the right conditions, it could multiply and evolve, giving rise to a new ecosystem, a new chapter in the story of life. The resilience of life is a testament to its tenacity, and its ability to adapt and survive in the face of the most extreme challenges. In the grand tapestry of the universe, life finds a way.